All right, let's get started. Hi, everyone, and welcome to our webinar, All Things Complex Payloads. We've got two amazing presenters today, being Huw Price and Harry Burns. Go to the next slide, you're beautiful. So we've got Huw Price here, who is the co-founder and chairman of Curiosity. Huw is a serial test data inventor who's also worked with the world's largest organizations to transform their test data management. With Curiosity software, Huw leads on crafting innovative solutions, drive test data and quality success for our enterprise customers. We also have Harry Burns here, who is Head of Solution Engineering. Harry is a test data management and visual modeling specialist. Since 2020, Harry's worked with some of the largest global organizations across finance, banking, healthcare, manufacturing, and helping them to solve complex data generations, compliance, and quality challenges. Quality challenges. So there's a bit of housekeeping before we jump in. So we've got a couple chat options, as you can see. So we've got your interactions, your Q&A, public chat, and private chat. So if you want to send one of us a personal message, not for anyone else to see, just use the private one. Anything general is pop it into the public one, and we'll get back to you either through chat or at the end for questions. Also have a couple polls that will be going throughout to be a bit interactive too. So Huw, take it away.
Hey, Sophia. Thank you very much. That was Sophia Ryan, who did everything brilliantly apart from introduce herself. So Sophia is our new head of marketing and has been with us for about 6 weeks and is storming along, shall we say. Right, so let's get on with it today. So let's have a look. Okay, so some of you may well have been to some of our webinars before, and we've talked about all sorts of various different things. This is kind of our loose sort of architecture or I guess diagram of components or use cases or whatever. Now today we're going to be sort of focusing on the kind of flat files, EDI files, rather than databases, etc. And obviously we'll be talking about a bit of data coverage and some data pipelines, because obviously you've got to kind of string all this together. We will talk a little bit about some of these other things as we kind of touch upon them, but that's really kind of what the focus will be today. So let's get into it. I'm getting a little background noise. If someone just wants to mute out, that'd be great. So complex payloads. I was wondering what to do with a title for this particular webinar, but it really is all about payloads. We're probably spending at about 60 to 70% of our time working with customers now actually dealing with the vagaries and wonderment of the actual content of the payloads that are flying around within organizations. And really, they are the new glue that connects your kind of business together. They drive the majority of AI-driven and business intelligence decisions. If you look at LLM and training models, they're basically large, vast chunks of data and JSON messages and all sorts of things. They can be a mixture of semi-structured and structured data as well. So they can be, some JSON, but then within that you might have some kind of floating structures within them as well. So it's a real mismatch in terms of the payloads that are out there. Now, the thing about it is that really each payload structure is really a world of its own. We did a webinar on AI testing, and I was trying to create some structured AI automation, and then I started deliberately to throw in a few dodgy messages, and AI went off into orbit because it couldn't really cope with suddenly having 50 or so messages which completely did not conform to the schemas or structures that it thought the world was. Now obviously payloads work in conjunction with other payloads. If you're obviously familiar with kind of Kafka messages or banking messages, they tend to travel around in streams of messages, and obviously those messages can also arrive in different orders, so that's something there to consider as well. Now the other thing really to think about is the payload has evolving metadata and data context. So fine, they added an extra element, but some of the rules of other elements may well change. So there is kind of a glossary or various enumerations or documentation. So although the data looks the same, it may well have changed over time. Payloads hunt in packs. There are chains of interrelated messages, as I said before. And when you come to sort of integration testing, you may well end up with a sort of 2 or 3 or 4 messages. Some of them may be virtual responses, and some may actually be kind of inputs. And then, of course, there's the expected output, which is then supposed to match with the eventual message that is being produced in another part of the system, for example. Now, the other thing that is sort of completely forgotten. Rule of thumb is you should have 10 times as much bad data as good data in your testing. Payloads often contain bad data, and lots and lots and lots of bugs, and a lot of my famous war stories involve bad data creeping in very early into systems and then causing lots of trouble later on. So, being able to synthetically create, for example, bad data, and also to analyze how much bad data there is, and also to model variations of bad data to make sure that you really are stressing out your AI, API, document management system, etc. Now, obviously, the biggest issue really is you can't easily see inside payloads. It's kind of difficult to see patterns in terms of what's going on. So, how good is my data to test with? I mean, we did a big project for a large phone provider, fruit-based phone provider, many years ago, and they were just using messages, and they were saying, "Yeah, here's the results," but they didn't actually know whether the queries they were running were correct, because they had literally done zero analysis of what was actually inside the payloads to really truly validate that their expected results were were correct. Sorry, their actual results were correct. Now you obviously can't see inside payloads. It's kind of difficult to see a specific scenario. And if you look actually at some of these payloads, you'll find that a lot of them, what you'll actually find is people will find a payload. If you think of a credit rating can have quite a lot of activity in it. It's got credit history, it's got all sorts of activity in it, and that's being used to make a decision by an external provider to give credit or not give credit. And what people will often do is find something that's close enough and then kind of hack a payload to try and fake it to look like some kind of longer chain history or some kind of event, maybe increase the number, 2 bankruptcy events instead of 3 bankruptcy events. So being able to actually find information inside payloads is actually pretty tricky. Creating payloads to test and develop with is difficult. We'll get into AI a bit later. I've kind of seeded a question at the end to kind of talk about AI and where it fits in this. It has its uses, of course, and it's a good accelerator, but it's not the be all and end all. Now, what we're generally finding is a lot of manual hand cranking, and people using templates and then kind of parameterizing the templates up is probably the most common methodology that people use. And Harry's going to talk about kind of that, and then we're going to kick on into a more sophisticated and a kind of a thorough approach to be able to think about how you actually build much more sophisticated payloads. Now, the other thing to think about is payloads, and payloads are all sorts of things, but actually one key thing is virtual endpoints. When you're actually creating a scenario where you're creating an input file, what you're also doing is you're going to be hitting various endpoints along the journey of that message. And what you often want to be able to do is to be able to create the virtual endpoint so that the message will carry along happily through its journey, and you're not, if there isn't a broker code with that, with that particular broker code amount or something like that, then the message will fail. So you don't just have to think about the sort of boring message at the beginning. You can think about all of the other messages, and service virtualization is extremely useful to kind of supplement your kind of API and message testing strategies. So, I mean, basically payloads, they're kind of everywhere nowadays. Everything is, we were talking to a healthcare company yesterday, and they were showing their kind of their data, one tiny part of their data flow, and they were sort of Kafka, Snowflake. There was just so many different transformations all going along, and each one of those is basically streams of messages and payloads moving through the organization. Now, pretty much in the old days, there was kind of lots of batch files. They obviously still exist, data take-ons, customer uploads, etc. Lots of mainframe stuff deals with that. There's obviously, the sort of the IBM mainframe message layers. But then Kafka and all the rest of them really do seem to be the kind of new ones that are taking over. And then your APIs, your requests and responses. You can create a request and a response. The request is what you're sending, the response is what you think it should be, and you can use those to validate your actual and expected results. Obviously, business decisions, traditional, this would be business intelligence, can be sitting on top of a data lake with you casting all sorts of queries against it, and of course LLM and AI. And then obviously the virtual responses, which then can help along in the journey when you're kind of moving through that world. So what we're going to start with is Harry's going to kind of do a kind of top and tail this. He's going to start with kind of a basic payload, how to create a sort of basic set of message structures, pretty quickly. And then I'm going to get into some of the more kind of nitty gritty advanced techniques. And then we're going to come back to Harry, who's going to then start talking about modeling variations so that you really do drive better coverage. You okay, Harry, to pick it up? I'll stop sharing. And you can...
Yeah, I'll jump right in. Let me get my screen up. Okay, if you could just let me know when you can see my screen there.
Yep, we can see it.
Okay, fantastic. So Hugh's already alluded to it, but central to everything you're going to be doing with regards to payloads is going to be understanding their underlying structure, right? The relationships, the rules, and the metadata that defines them, right? So what we have inside of our platform, and what is quite a common tool nowadays, is we have the concept of a data dictionary, right? So when we're working with something like payloads, what we will try and do is we will try and create some sort of definition, right, of that structure of the payload that we're working with. And that's going to be central to everything we do and all of the activities and jobs that we build as we go forward. Right. So in terms of creating these definitions, there's lots of ways we can do it. Now, typically, what you would hope for is that there might be some sort of schema out there. And what I like to do when I sort of demo this initial creation of a definition is I use one that's quite complicated. So I've had a lot of experience working with sort of payments messages, in fact, with like financial institutions, and ISO 20022 is the new format, and that would be a sort of payload for some sort of payments message, right? And that would be an XML message. So what I have done is I've created a definition here by scanning the schema of the most common payments message that we have in ISO, and that's known as a PAX 8 message. So if we come in and just take a look at this scan here, what you'll see straight away, and with various views that we can sort of come in here, there's a diagram view, tree view, is it's come in and it's brought in all of our different elements, the structures, the different headers, and what type of child groupings exist, whether they're sequences, attribute groups, choices, etc., etc. So, if we take a little look in here, what it's also done, we have some intelligence in the tool that is actually extrapolating out the kind of ambiguous ISO names and giving us a sort of real metadata name here. So rather than MSG ID, we can see that that's a message identification. And if we came and we sort of dug into this in a bit more detail, you can see it's also pulled out all that key metadata. So we've got how many times does this have to occur, minimum length, can it be null? And this is all going to be really important information, right, when it comes to actually configuring up a generation rule set and creating data that's going to be usable and valid. So the other important thing to note when it comes to building up these definitions is it's all about being able to maintain them, right? Understand how things have changed between versions. So once we have this sort of initial scan and some sort of schema that we've got linked, we actually create a definition, okay? Because definitions can change, they are versionable. Scans are a sort of unchanging, unique thing that happened. So I will quickly open up our PAX definition, if I can track it down. Great. So we've got our PAX definition, and what you'll quickly notice is this is all versionable. as things change in our worlds, there's a new release, new requirements, the scheme has been adjusted, we'd come in, we would create a new scan, we would upgrade the version, and it would give us some sort of comparison as to what's taken place. You can see here, again, we sort of have the similar information that we've had inside of this scan, but it is something that we can change, we can manually edit, and is adaptable, right, as we go through our testing cycles. The database view you will be getting onto in a minute, but that is another way that we can sort of break down this information and we can start to do more clever things, which is where we're going to be getting to on this. So we have our definition. Now, how do we go about sort of building our generation rule set? So what we've been doing for a long time and what we're starting to improve on is we've been using sort of these templates, right, in order to generate data. Now, if I get up one of my data activities here, you can see that I have a PAX 8 generation. I've got my definition that I'm working with, and what I've got is I've got some sort of generation rule set. Okay, so inside of this generation rule set, what I've done is I've configured up all of the key information as to what things I want to parameterize, what synthetic functions should be used, what elements I want to admit, how I want to randomize things. And there's tons and tons of accelerators that we can have in the tool for this. For example, applying defaults. You can use sample data in order to narrow down the payload that we want to work with. And parameterization is, of course, the last thing. So this will be really important later when I start to show you how we generate for coverage. But you can see here that I've parameterized up things like payment type, currency, amount, distribution, and optional tags, so format of the message. And then I've also parameterized up specific aspects of the message, so number of transactions, currency, and I think it was settlement type. So I've built this generation rule set. At the moment, this just lives as a template, right? So you can see we've got a little option here called generate our template. What we would do is we would generate that template, and that would automatically be linked here to our activity. So what we can now do is we can come in here and we can generate the data we need in some sort of format, right? You can see here I've got a nice form. We've got all of my different parameters. So, for example, what currency do I want to use? What's my bank settlement amount? When's the credit date time? Which optional tags should I include? Do I want to do edge cases, typical? Do I just want minimal tags? All of this good stuff that I've parameterized and defined in that rule set is being exposed to the data requester so they can get the specific payload that they need. Right, and again, this form could be triggered through a pipeline, could be triggered through the API, anything like that. Now, there's limitations to this, right? The problem with using just templates is we're going to start struggling with things like cardinality and repetition. When we have nested repeating elements, we get things that we struggle with hard-coded loops. Elements start to become fragile. Choice logic becomes deterministic, right? So we risk sort of populating mutually exclusive branches. Again, that's why we're sort of thinking, is template generation really the best way to do it? And it's also parameterization and distribution control, right? So variation requires a new template, right? If we're changing the structure too much or changing lots and lots of parameters, it becomes a lot harder for us to control that with a single template. Whereas if we're extrapolating the structure of our message into a database, that becomes a lot easier to control. And the last thing that we'll sort of look at as well, after Huw sort of showed his bit with how we're using databases to solve this problem, is how can we be more advanced than just requesting single payloads at once? We don't want to just be getting a scenario and a single set of data one at a time by submitting this form. We want to think about the whole picture, all the scenarios, the variations, edge cases, all that good stuff. So I'm going to take a pause here. This is the world at the moment. This is what you might typically be seeing. This is what we've been doing for a long time. I'm going to pass over to Huw, who's going to show you the new and exciting stuff we've been working on.
Hey, thanks, Harry. Let me just share my screen back again. And should get... okay, can you guys see that? Understanding payload content?
Yep.
Okay. Okay, so now basically what we do now is that we can in fact convert pretty much every single message that you ever came across into a database, shredding and parsing that data. And inside the product, we have a little micro DB where we can create the structures, and we can use that to store data. And we can also use that data to generate data and update data. So now, once you've started to take a ton of messages and chuck them, initially, we just kind of do the initial analysis, which was the scan it, which was the definition that Harry was showing you, and then out of that we will create a database structure. From that database structure, we can push the data in, and we can then take it into that database. Now that allows us to do trend analysis. So quite often people say, well, how good was your message? How good was the testing for this particular run? You have no idea. It's just a bunch of messages. It's the same message we used last month, and we did we added a few extra ones. That's pretty much the best that people come up with. You don't really have any idea of kind of attribute coverage. Also, once you have it inside a database, the ability to do machine learning analysis, CT-GAN type analysis, etc., is massively enhanced. So you can actually then just use the kind of normal CT-GAN type advanced machine learning techniques, which basically is actually more advanced than AI itself, by being able to actually look at the data in a database rather than it trying to analyze 12 million rows of JSON, etc., etc. The other thing is data validation. You can actually very easily run data validation on it, and also you can actually just it's much easier to identify bad data once that data has actually made it inside a database. You can just run a bunch of queries and say, well, how much bad data have we got in there, rather than having to manually look at files. Once you've also got it in there, you can recreate those messages on demand. So once you put them in, you can chuck them out again. You can update the message content if you want to. So if you want to age them, if you want to mask the data, for example, you've got a whole bunch of VDI files, we put them in, we do the analysis, we mask them, and we send them out to some suppliers to do some work for us, etc. So that's kind of the core brains of the operation. So let's just talking about, I'm going to talk about a couple of use cases, and then we'll get into some more demoing. Now, one of the issues with testing AI, I'm actually off to Eurostar in June. If any of you guys are going, then feel free to come say hello. Basically, that's all about testing LLMs, etc. And the biggest problem with AI is if you don't know what you have, it's impossible to verify AI is giving the right answer. It's a black box in terms of what it's up to. And if you don't know what you're giving it, you're giving one black box, another black box, and then it's giving you some answers which you're betting the farm on. If you're testing a prompt, one prompt at a time, trying to actually use real data to test that prompt is just, it just takes a long time to find all those things. Just generate and test each prompt on its own and start testing them in conjunction. Putting them into a SQL database, you can create SQL. Actually, AI is very good at being able to create the SQL to build you an analysis. The advantage of the SQL being created is that it's deterministic. You can actually verify the SQL that's created is correct to do the analysis of the data. You can create the complex payloads, and then you can run your prompts. So you can actually generate the complex payloads and run your prompts, and then you can understand the output, adjust the prompts, and repeat. So you end up in this kind of virtuous circle of being able to generate complex payloads, match them to the prompts, repeat them. As you add in more prompts, you can rerun the same payloads. Now, remember, payload may well be date sensitive, so you constantly need to be updating the dates of the payloads, etc. And obviously, once it's in that database, you can use SQL to verify the AI results matched with the prompt payload combination. So in other words, you set up a systematic system where payload development and testing are intertwined with the LLM development. Focus on bad, missing, and empty data. AI, I cannot tell you how often AI gets it wrong once you start giving it some bad data. It really does go off the deep end, and it's quite fun actually just throwing a bit of bad data at your prompts to see if you can actually get it to tell you to sell a house or buy a house or whatever. Create an automated framework. So this actually is a quote that was, I think someone posted this on LinkedIn the other day. I'm just going to leave it here for a little bit just for people to read. And I think he's caught the kind of zeitgeist at the moment, which is basically, or she possibly, I think it was a she actually. It's basically, in effect, what we're saying is that we now live in the world of APIs. You know, everything is an API. You know, whether it's SAP, whether it's PeopleSoft, you know, whether it's a Facets database or whatever, that data is coming out either as Kafka messages, which are being fed somewhere, or they're going into payloads, etc. And the reality is that you know, businesses really aren't that good at it, and they haven't really got the expertise to do it. You know, and they haven't really thought about how to build really strong automation, sort of develop, automate, test, develop, automate, test structures, you know, and version manage it as well. Now, the key thing about this, obviously, is that you need to think about data. You know, the payload is the data, and if you can really go to town on building the right data and pushing that data into your APIs. So whether it's AI or APIs, which are probably the two most, APIs is probably the most useful one at the moment. AI is still kind of, the jury's out, and people are still doing a lot of playing, but certainly over the next 6 months, it's going to be the kind of the new rocket fuel, I guess, in terms of being able to create all the data and really rigorously test your LLM to make sure it's not giving you poor business decisions. So just to kind of summarize it, we parse the data, we shred it, it puts it in, you can create the files on demand, and you can push them back out. So let me just quickly kind of show you what that looks like. Now, so I was just actually, so I'm quite fond of DocuPipe. It's a good little product, and it's very good at being able to. So in this particular example, what I was working on was actually, we had a subledger, which, you know, it had a sort of a structure to it, and I chucked it over to DocuPipe and said, right, go and have a look at this. Build me up the summaries, transactions, reconciliations, etc. And out of that, what I really need to do then is got journal cross-referencing. There's a lot going on in this one subledger. If you think about it, it's actually, like I talked about, the world of its own. And we threw that into DocuPipe. That gave us a JSON structure. And then what we've done then is kind of gone to town on that. So let's just jump over to now. If you look at I actually extracted, I'd had a whole bunch of messages, I extracted them, and then this is basically our little micro database sitting in the back. And what we've done is we've populated groups of data into the components, and it actually breaks the JSON structure down into these structures. And what we've also done then is we've created basically an aggregated view of the data sitting inside here as well. So not only have we got the individual transactions, individual message content, or in this case, document content, what we've also done is we've created an aggregated view which sits on top of it. Now, what we can do is, this is just our pipeline tool. Some of you may be familiar with it. Now, what we could do is, I've got two different examples here. If I go back here and say, run 116, let's just pick up that was a group of messages that were created previously. They could have been imported or they could have been generated, and what we're going to do is we want to recreate that message, and we're going to go 2026, and I'm going to set it up for tomorrow, because that's when I'm going to be doing my testing. So in other words, I'm pulling the data out. That data is in effect extracting the data from the database and reassembling it back for us. And then if we look at the data, we'll see that we've created, that's the JSON message, which then fed into our document tool. You can see we've created the transaction date, you know, and all well and good. That's great. We can, basically, that's straightforward. We can put it in. But now we say, well, okay, let's get into actually generating some new messages. How many documents do you want? How many categories? Now this gets into some of the stuff that Harry was talking about. Now, if you look at here, what we've done is we've kind of broken down the structures like so. So, you know, these are in effect the repeating groups, and there are actually 3 different groupings. You know, you can see, even though this is just one document, you can see there's a lot of stuff going on in here. And you know, this is so common in terms of how of how structures need to be assembled so that you can create a really rich set of document subledgers. Now, if you come in here, what you'll see is that you have this ability to control individual repeaters at this level. So if we go down to this one and look over here, you can see maybe I want to make that a range. So in this particular case, I want to have between 1 and 4. Now, what will happen is when we then go off and actually request our data, let's between on the category summary, we're going to have between 2 and 4. How many documents do we want? 3. How many categories? 2. Transactions. Let's increase the transactions. And you can basically very easily go off and actually just play around with these repeaters, and gives you really great flexibility because, you know, it's just going to a database. We can handle all the repeating, the sub repeats. We can do all sorts of clever things with summing stuff up at the end, making sure there's sum totals, and that will fire off a job, and that job will then basically create you that document with all of the repeating groups, etc., etc., etc. So that's really kind of taking it from a JSON structure, putting it into a database, and then being able to recreate it. For the reality is that actually setting this whole thing up probably took like less than 20 minutes. Most of it is just done with a whole bunch of accelerators, so it's pretty straightforward. And Harry will talk to you a little bit about some of the kind of AI stuff as well. Now, one of the other things to think about is if we think about the data that's going into, let's just look at the data for our expenses. What we can also do is we can start sort of doing some analysis on this. So we could look at, so let's look at customer city states and balance units, maybe expense units, category names. So what we're doing here is we're basically doing spot diagrams. Greens means we've got a high volume of them, red low, yellow medium. And what we're doing is we're basically just showing the different variations of attributes in the messages that we have in our current data store. And the idea really is, what you should think about is, and AI is actually pretty good for this, is to be able to actually generate you know, really rich combinations of data kind of sitting inside this MicroDB, which then allows people to request the data that they want. You know, so at the beginning of every test, I think actually Harry was working on for a bank, and they were producing about 10,000 messages a day. Each message was different, and we were really trying to sort of increase the sort of level of coverage using this kind of spot diagramming technology. So let's just carry on a little bit. And now I just want to go into find. Okay, so this one now is kind of an integrated test. I'm just going to kind of quickly show you. Now, in this particular one, what we're actually doing, this is we're kind of throwing the kitchen sink at this particular one. So I could create a scenario. So in this particular case, I'm creating a specific set of customers and orders, etc. You can see we've got all our repeaters, etc. But at the same time, we actually want to create a virtual response, like so. So we actually we need a virtual response which matches with the data that is going out with the orders. So we're creating a whole bunch of orders which are then pushed into the ordering system. Those then get picked up, and then those will create messages. But then we need to make sure that we have the shipping response messages that are associated with that as well. Now, I could use a scenario approach, or I could potentially use a model. I'm just going to briefly show you the model. Harry's going to get into this in a lot more detail. And what we've got here is, for certain types of orders, we've actually gone to town on different types of shipping variations. So what will happen is we end up with I think there's 57 different variations. Each one of those variations is a different type of shipping, so that when we actually create all of our labels, when we do our shipping at the end, we make sure that those labels are actually created you know, in a very nice and kind of covered way. If we go back to let's just go to this one here. The other thing to think about when you're building data, I talked briefly about children data and matching data. When you're generating data, and this applies to messages, here, for example, what we actually need to do is we need to make sure it matches with our mainframe. So we've got a connection into the mainframe. So when we're generating the data, what we can do then is say, well, okay, I just want to randomly pick out so this is banks. So let's go and pick out from that. And we're going to pick the, let's go to, yeah, we're just going to pick out some particular bank transactions. That will go through and be able to use the bank transaction data, and you can put where clauses on it. You can do all sorts of lookups, etc., etc. And that will then create you a variable, which you can then go off and use that variable inside, you'll see, existing band transactions. So you can come in here, adjust that, and that would then use that to actually populate the data with data that matches. There's the number of times I've seen people sitting there hacking XML messages, going onto a system, looking up an account number, cutting and pasting an account number, putting it in. You know, you'd be lucky to get through 4 or 5 messages a day, when really, you know, you should be churning out sort of 10,000 messages at the beginning of every sprint, and then supplementing it with hundreds of messages every day. So that's that one. I'm also just going to talk a little bit about some of the. Let me just go and just open up. Go to. This is DCC, which is the. This is one of the messages that. To do with the energy exchange. And what you'll see in here, these are the structures I think Harry was showing there. And what you see within this, you've got this kind of concept of choices. Now, choices are, these are a serious issue. If you kind of look at, let's look at here, you've got all sorts of different choices that are going on. So in other words, there's no way that you would be able to branch your way down without taking account of these choices. You know, if you hack together a JSON message, and you leave in a choice which shouldn't even be in there, that's an invalid message, but you wouldn't really know, because you've just kind of copied or hacked it. And we've got this ability to bounce through all those various different messages and look at all the different messages. And if we take a look at, let's have a look at this one here. Now, this particular one is FS tab. So if we look at this one here, what you'll see is that actually, sorry, let me just go to the definition so we can have a look at the definition again. So if we look at our definition here, you'll see that there is a choice view. Now, it's very straightforward, this. So if you pick random, that's great. And if you pick random, now, but if you pick storage 1, then you lose that one. Storage 3 has basically a sub choice. So we keep track of all those storages. That's really important. So when it comes to actually submitting the request here, if you pick storage 1, nothing. But when you get to storage 3, then it's going to require you to put in something like an IP4 or something like that. So I think that's something that's kind of really important to think about as well when it comes to actually generating these complex payloads. The choices, which, you know, it's easy enough to put them in, but actually managing them is really important. Now, to us, it's fundamental. It's built into the product. You wouldn't be able to create it unless you specifically forced it to create a bad message with an invalid choice. And there's one final thing, and then I'll go back to a little summary, and then we'll go back to Harry a little bit. So if we take a look at now, the other thing to consider, there are various other things you need to worry about with payloads, one of which is there's all sorts of things that you can do with kind of empty elements, and it is amazing the difference between how systems react when you have an empty element, in other words, a backslash, if it's an XML with no payload, or if it's completely missing, or sometimes people will include it with a null in it, and sometimes people will put a space in it. So there's all sorts of different things that you need to worry about when it comes to being able to kind of control what actually gets put out into your you end up that way should be missing, that one should be missing, this one basically should just be a backslash. So this ability to control the content of these choices is really boring plumbing, but when it comes to actual real world testing, it is utterly essential if you don't think about those. So in this particular case, and this actually would make more sense to be in a model, to make sure that when we generate the messages, we would then generate all the different variations of random values, missing values, empty values, etc. Also namespaces, sometimes in namespaces can be included, etc., etc. Okay, so that's a little bit more of a demo and kind of showing you some of the power of that. That's just a little bit I did before. Now, again, just when it comes to thinking about testing itself, once you start getting messages in databases, you create a message, you can either just ingest it into the database, or we generate the message, which would have obviously come out of the database. At that stage, we've now got an extremely valuable resource to be able to help us with our expected results. People's understanding of whether a test works is variable, if I'm being polite. Now, a good way to do that is if you have the content of the message in a database and you have some kind of result, maybe it's ended up in DB2, it is much easier for you to validate that that data is correct. Otherwise, you're doing all sorts of JPaths and XPaths and hoping for the best and writing all sorts of, Python script to validate that things actually work. So this ability to use that SQL is kind of critical. And once you get into coverage, which Harry's going to talk a little bit about as well, then you can actually really get into some pretty serious coverage where you're actually creating all the different variations. And at the same time, as well as modeling the data variations, if you can also model out the expected results, then out of that, you're actually then getting a very serious you're in effect designing what your actual results should be as part of that model, and you then have the capability to validate that the input, which is now stored in SQL, and the output, which is generally stored in SQL, you can, or even if it isn't, it's a message which we can convert to SQL. Your ability to systematically and automatically validate that your expected results match with your actual results. Now, obviously, one final slide on this. The other thing to think about then is change. Once you've got your automated framework, for example, even this that K-Expense one, where I was basically creating all those subledgers, those are sitting there. I can create them on demand, but they are then being ingested by a system. That system changes. I want to be able to make sure that the API, which is the thing that where I upload those messages, is it behaving differently? What's it doing? You already know from your previous automated runs what the expected results were. And what you can also do then is just rerun it and just compare the expected results. Now, the actual results even, if at the end of it, you've got some kind of summary total, this has created an invoice or something like that, you just ingest the invoice amount should be the same. So, if all being equal, then you have this ability, once it's inside SQL, to really go to town on that type of thing. Okay, so that's that. The other one, we've done a little, there's some videos on this one. Basically, the other thing is people spend an awful lot of time hunting for messages. Once we've got it in the database, then you can actually then just go off and use AI to help you scan through that data to look for the characteristics. I need a long chain history with a credit with more than 2 bankruptcy events and 3 changes of addresses. Find me a message that I can then use to test with. So that's something that as well that's really kind of useful. Right, so what I'm going to do now is just hand over back to Harry, if that's okay. So I will stop sharing.
Yeah, I will take over. Okay, thanks so much. You just let me know. Looks like my screen is up. So
it's there. It looks good.
Yeah. So going back to sort of where I left you guys with you. So in terms of parameterization, right, and getting specific variations of data, that hasn't changed, right? Just our flexibility of the actual generation as of what we can do with the information about the messages. But if I can take you back here, we have our form, right? And, I parameterize up some things that we've got here: currencies, amounts, distributions, optional tags. Now, what we want to be able to do is drive this in some sort of logical way, which is going to give us a big spread of all the different variations of message that we care about. So how we do that is through what we call a generation model, right? So you can see here, linked to my activity, I have a PAX8 generation model. Now, it is actually a lot simpler than it looks. So we'll just give this a second to load. Now, what we have here inside of this flow model is we have a start state and an end state. Now, in this model, we're just modeling out data. So I've got, depending on my data, I'm going to have a valid message, or I'm going to have an error code. Now, Huw touched on this before. It's so important to know, based off all your combinations of data, what do we actually expect to happen? Otherwise, are we really testing, right? So, when I'm doing this in practice, there may be all sorts of different error codes that we're expecting. There might be specific warnings for certain types of payloads, different responses. So, depending on all of this data, which I'm going to talk you through in a moment, we're going to have sort of and the starting states, we're going to have different or sort of expected results that we're modeling to. And in terms of the data that we're modeling, what we have here is we've exposed our parameters. So, for example, you can see here we have currency, and I've modeled out the key variations that I want to test. Now, this could be edge cases, boundary tests, key equivalence classes. In this case, I've gone for pounds, dollars, euros, and I'm also testing an invalid currency. But this could be anything, right, that matters for you to validate your system. The same thing goes here for sort of number of transactions. I've set sort of different ranges that I care about. I've then also got some key financial institution test BICs. And then at the end here, I've also got various sets of optional tags that I'm going to include or not include, depending on how large and complex I want the message to be, and also the charge bearer key variations that need to be validated. Now, what this lets us do is, instead of going and sort of generating record by record and trying to get all of our scenarios essentially manually, right, trying to come up with them by ourselves, we have a nice, neat model here of all the things that matter in our world, the business rules of the data, and the expected results based off the combinations of that data. And from this, what we have is a real powerful, essentially like optimizer, where you say to it, okay, based off this model I've designed, I want some level of coverage, right, for my test cases. So here I've got all pairs. So what I'm saying is, based off this data model I've got, I want to test all pairs of data, all of these different combinations. And I can save this, I can click generate, and our backend algorithms are going to read this model, and they're going to give us all of the different scenarios of data, right, and their associated expected results. So if I just zoom out a little bit, it's quite easy to visualize. You can see how I've got 107 different paths. Each of these paths, as I click through them, represents a unique scenario of data and some associated results. So just building this model again took me 10 minutes, 10, 15 minutes, and straight away I can go and give myself 107 unique different data combinations that I know are testing all pairs of variations within my, that I could possibly want to look at. So unbelievably powerful, really fast. Just to give you an example here, for this test case, low bank settlement amount, pounds, medium number of transactions. I'm choosing these specific financial institutions. It's a shared charge bearer and minimal optional tags. So that's one scenario of 107 different ones that I've got. And this can be even more clever. You can be targeted in the test cases and scenarios that you build. So what I did in this model is I actually added in some tags. Okay, so you can see here there's something called key paths. And actually, all I care about at the moment is I want high coverage through my key paths, and I don't care about the rest of my data model. And what I'm going to do now is I'm going to generate a new set of test cases for this specific cycle, or for this specific bit of testing that I'm going through, and it's just going to give me that specific combination of data that I looked for. So you can see here pounds and a high number of transactions. This is what I I set as my key paths, it's giving me that specific piece of data. And again, if I wanted to sort of just do low coverage and make that exhaustive, I could bump up that number a little bit more as well, right? So it's really, really useful in coming up with targeted test suites. So you can see here for exhaustive coverage, I've got on my test environment here, I've got a limit of 1,000, but this could be tens of thousands, hundreds of thousands. It's quite a complicated model. So when you go to exhaustive, it becomes quite a large model. Now, the last thing I want to show you guys before we just do a bit of Q&A and talk a bit more about AI is you can also use some of our agents to help you build and analyze these data generation models. So if you look at the top here, we have our little Copilot equivalent, and we have tons of agents in here that you can extend and build yourselves. But what this allows you to do is it allows you to use the AI to assist in building and looking for gaps inside of your generation models. So if I wanted to come in and sort of do some requirement gap analysis, I would run this agent and I'd say, what scenarios haven't I considered? And I can use the AI to look at this data generation model and pick up on things that I'm not testing, right? So I've already got a nice model that's quite clear to me what I'm testing. But hey, if I have missed anything, the AI is going to pick that up rather than us scrambling around manually trying to come up with each of these scenarios and create them one by one. So yeah, really, really valuable tool that we have to sort of get high coverage and certainty about what it is that we're testing and all the data we need. I think
cool.
Because I know we want to elaborate a bit more on AI and answer some questions. So let's take a pause.
Yeah, can you hear me?
I can hear you.
Yeah,
I can hear you.
And you can see a couple of slides, then we'll take some questions. Okay, so complex management, you need a central dictionary of structures, history, data rules and lineage, description of data elements and numerations. Actually, once we got it inside a database, we can do some really, really deep analysis in terms of, using some of the machine learning algorithms to actually really, really, truly understand what's going on with your message packs. You need to be able to create complex payloads by handling choices, references to external systems, and references to sibling messages. Things. So all of these things are so crucial. The thought of doing any of this by hand just sends shivers down my spine. You really need to be able to think about doing this as an automated way. You need to be able to model requirements of the payload business process, which Harry was just talking about, predict the expected outcome based on the data you've created, and model the variations of the payload content. So that's really kind of what we're about. Sort of core recommendations: parse your payloads into a MicroDB, analyze different groups of data, validate the data content, understand it, central dictionary, integrate the payload into your automation. I think this is really the key point here, is that building automation frameworks. I mean, most people can knock out a bit of Python nowadays. There's plenty of API and frameworks floating about the place, so it's pretty straightforward. Create models of expected behavior, build those, include the expected results as an output of your automation, so that then you can use that later on to validate that your expected and actual results match. And then the other one is, don't forget the bad data and integrated data. Creating lots of bad data is just cannot be stressed how. Just do that as phase one. Just create so much bad data and make sure your validation kicks everything out before it even gets in the system. I think that's probably the thing that will stop the biggest bugs you're ever going to get in production are some bad data that got in and has made its way somehow through the system. Disentangling that later is a nightmare. Okay, so that's it. Obviously, love to talk about your payloads, love to talk about any API testing, anything you've got going. So feel free to just ping myself or Harry or Sophia, and we will, basically the best way to do is just kind of do a little workshop, show us what you got. We'll kind of talk around what some other customers are doing, some best strategies and best approaches and things like that as well. So I think that's about it. Sophia, do we get any questions?
Yeah, we had a couple. So firstly, you're mentioning API testing. How do you plumb the payload content into like a joined API chain?
Yeah, so I think I mean, we have a pipeline tool which allows us to invoke request responses. But it's not really. It's kind of our tool, and it's most of our pipeline tool is designed to be called by other tools to provision data, etc. So generally, there are just go out and look for an API payload. A payload tool. Most people tend to do it by hand with Postman, which is just not very systematic. But there's plenty of tools out there. So what we do is we basically create those structures, and you just need to have a little harness looking for the message structures, the requests and responses, whether they're XML or some kind of JSON, ingest them, and then fire them off and return them back into that. So we can help you set that up. It shouldn't be too hard. We already have a set of Java libraries which allow you to call us. And then those Java libraries you can monitor when the payload's created by us, and then you could then just ingest that payload and put it into your API and just so forth, etc. So that's that one.
And there's just one more. It was, how do you compare against AI-generated payloads?
Yes, so I'm going to start, and then I'm going to unleash Harry on this one. I mean, the reality is, AI is good. There's no doubt about it. I mean, you can basically say, great, here, here's 500 JSON payloads. Create me a bunch more. Brilliant. The trouble with AI, it changes the next time it gives you the messages. It's extremely it's not. I'm not going to say deterministic. It's not reliable in what it is determining. It may change its mind. The other problem, of course, is that once you actually get into the real world of actually trying to make that payload actually fit into your world, you need to know every single thing about. You need to be able to create the virtual messages. You need to be able to make sure that the system it's attacking has the right codes associated with it. So the message, when it's created, needs to actually contain real data which matches with your other systems. Otherwise it's just a useless message, and you've got to go through and manually make those changes yourself. The other one is the abstraction away. The real power, which is the stuff that Harry was talking about, really, is use AI to build a better model and leave an industrial strength tool to build the plumbing of the message, which is kind of what we've been really showing you. Harry, do you want to just kind of go in on that one?
Yeah, I'm actually I kicked off that job as I sort of shut down earlier, but this is exactly what Huw's talking about, right? Which is, rather than using it to do something which it's not really great at, use it to build on top of our deterministic generation and pick up on gaps or be an accelerator. So I sort of ran this requirement gap agent as I was just sort of signing off there, and you can see here it's given me all sorts of suggestions of things I can add to my model, right? So for example, lowercase currency formats, non-numeric values, different sets of transactions, specific error codes, charge bearer code completeness. It's suggesting I'm missing one. So there's all sorts of stuff here that the AI is giving me that can help me test more vigorously. And this can be applied to sort of the initial creations of models, all that sort of stuff. I think also, if we're being realistic, like when you ask AI to do things at massive scale, it does start to leave things out. And it isn't deterministic in the way that we are, right? So I think you're going to struggle with things like nested repeated groups. You're going to struggle with all of this choice executivity, min-max occurrence, referential integrity, as you always touched on, right? Cross-field dependencies, all of that stuff. AI isn't doing that deterministically. It's doing its best guess at it. So when you put that into scale, especially in fields where we're highly regulated and it has to be correct, it's not reliable. So use it as a tool for accelerating, for building on deterministic outputs, and you're going to get better results, I think.
Yeah, I mean, we've got AI blasted throughout our code. Anyway, so anything that AI can help you with, but you can see it. The thing about AI is you need to be able to observe what it's done and verify it. If you let it do its own thing, then that's it. It's gone. You have no idea really, unless you plow through 500 messages and make sure that it hasn't done something silly in there, by manually doing it. It's better to have something which what it's doing, including all the bad stuff and all the good stuff that we did, and then take AI to create that model, which you can look at and you can verify. So, humans are the guardrails, really. But to do that, you need to break it up into the small chunks. So I think that's a very good point. Very good question.
Yeah.
Okay, so I think are we done for today?
On the minute.
Wow, we've actually hit 5 o'clock. That is extraordinary. I think that's the first time we've ever calmly come to an end of a webinar.
Perfectly.
Okay. All right. So thanks, everyone. As I said, we're very happy to chat. So just ping us a message and we will get in touch, have a look at some of your payloads, see some of your challenges, whether it's documents, AI testing, APIs, whatever. And let's just talk and talk about what other people are up to as well, best practice and the like. Great. Thanks, everyone.
Cheers,
Bye-bye.
guys. Thank you.
Bye-bye.
Yeah.
Bye-bye.